Welcome to another video on statistics, and in this video we will learn about histograms. So the three things to remember about histograms are that histograms are used to represent continuous data. The area of each bar, as you can see here, is proportional to the frequency of each class, and the frequency density, which is on the y-axis here, can be calculated using the formula area of the bar divided by the class width. So let's have a look at the first example. So this histogram on the right shows times it took to solve puzzle by random people, as you can see here. The number of people who completed the puzzle in more than 40 minutes was 15. So from 40 until the end was 15 people. And we will learn how to complete the frequency density axis to find the number of people represented by each bar, and then finally the number of people who took less than 18 minutes. So let's start by doing part A. So more than 40 minutes was 15 people. See, 40 minutes is here. So we have to calculate how many squares are there in the, so in the last bar, it's 5 times 525 small squares, and in this second half of this bar here, base is 5, height is 10, so this is 50. So altogether there is 75 squares in 40 minutes or more. And if we divide 15 by 75, we can see that each square represents 0.2 people. The last bar, which is 5 people, because it's 25 squares times 0.2, and so the frequency density, which is the height of this bar, must be the area over base, which is 0.5. So the height of the last bar is 0.5, which gives us the scale. So the 5 small squares vertically is 0.5, which means that 10 small squares will be 1, and so on. In part B, we are asked to find each frequency in this table. So once we've got the frequency density, it's quite simple, because it's just base times height. The base of the first bar is 10, height is 1. Base of the second bar is again 10, height is 1.5, and so on. You only need to be careful. This bar here doesn't have the width 10, but it's 20. And if you do 20 times 1, you will get 20 people. And finally, looking at part C, find the number of people who took less than 18 minutes to complete the puzzle. So 18 minutes is somewhere here. So there are two ways how to do it. One way is to use the frequency density. So we can see that the area of the first bar must be 10. The area of this second bar from 10 to 18, base is 8, height is 1.5, which is 12, which gives us 22 people. Another way how we could answer part E is we don't actually have to use the frequency density, but we can use the scale that we found in part A. We already know from part A that each square represents 0.2 people. So if we calculate number of small squares between 0 and 18, we will get 110 squares. And if we multiply this by the scale 0.2, it will give us the same answer, 22 people. Now let's have a look at the next example. So you can pause the video and try to answer this question on your own, and then we will go together through the answers. So let's start going through the answers. Part A. So there were two missing frequencies, and we know that class 3 to 4 is both in the table and also in the histogram. And in the histogram, we can see that this area is 65 small squares, and it corresponds to 13 customers. If we divide 65 by 13, we can see that each customer corresponds to 5 squares. So class 2 to 3, which is here, is having 125 squares. So this will give us 125 divided by 5, 25 customers. And then the question said that the total number of customers was 112. So if we add all the other frequencies together and take them away, we will get for the missing number for 4 to 6, 7 customers. And finally, we were asked to complete the histogram. So the area of the first bar is, because the base is 1 and the area is 64, we need to find the height, and height is 64. The fourth bar, which was missing here, the base was 2 and the area is 7, and if we divide 7 by 2 we get 3.5, must be height, 3.5 small squares. And finally the fifth bar missing, which was here, the area was 3. If we divide 3 by 2, which is the base, we get 1.5. So the last bar has got the height 1.5 small squares, and we didn't even need the frequency density. So that's the end of this question. Thank you for watching.